3 and 3.4. You should have gotten this paper from Mrs. Weinman. It may be purple or a different color. The 3-4 notes are on the back. And basically the notes, we are just going to kind of go through a few different practice problems. Some I'll do with you and some you'll do on your own, just to make sure you understand the process. So basically we have multi-step problems going on here, multi-step equations in 3-3. And the steps up at the top, number one, it says change subtraction to adding the opposite. You don't always have to do that, but you really need to do it, especially when there's a subtraction sign in front of a number that's going to be distributed. Because this is actually -3, and that -3 is going to be multiplied to both of those terms. If you forget to change it and you distribute a +3, you're going to get a totally different answer over here of a +6, and it should be a -6. And then step 2 is distribute, combine, simplify. And you may have all of those steps, you may not have all of those steps. So we're going to do this first one here. As you can see, we have some like terms. The 3t and the 5t are like terms. We put them together to make 8t, and then 8t minus 5 equals 11, and what do we have? We have our normal two-step equation. So we add 5 to both sides, 8t equals 16, divide by 8, and t equals 2. Now, on all of these problems, you can check your work. Every problem we've been doing in Chapter 3, you can check your work. Then you'll know if you have 100% before you turn in your summative. You'll know before I will. So to check it, we would plug it back in for t in both places. So 3 times 2 plus 5 times 2 minus 5 equals, with our question mark, 11. And then you do order of operations from there. So I have 6 plus 10 minus 5 equals question 11. 16 minus 5. 11 equals 11. So it checks, so I can be sure that t equals 2 is correct. Okay, you're going to try this one. You're going to distribute the -3. So if you don't change it to plus a negative, you're going to have a problem. So go ahead and distribute, pause the video, and then come back and see how you did. All right, so in this guy, did you get a equals 14? When you distributed, that was a -3 there, so you end up with -3a plus a -6. They make a +2a when you combine your like terms, and then you solve your two-step equation, and then did you check it? If you checked it, you knew if you got it right or not, okay? And it was 22 equals 22. All right, so let's go to the next one. Here's another one right here. I'm going to just demonstrate this one together, and I see distribute right in the very first step. Just because the 40 is on the other side, that doesn't change the problem. You could actually make it equals 40 on the other side if you wanted to. I'm going to make this plus a negative now. I could have done it in my first step, but I want to make sure when I combine my like terms, I get a -10k and not anything else. So that equals 40. And then I'm going to do my two-step work. So subtract 20. 20 equals a -10k. Divide by -10. K equals -2. And I'm going to tell you that it's right. You can certainly take the time to check it by plugging it in there, but it does work. Okay, let's look at the next one. We have 3/4, and it's being multiplied by that a minus 5, that quantity of a minus 5. So we need to get rid of 3/4. So what's the opposite of multiplying by 3/4? Well, the opposite of multiply is divide. So really what I need to do here is divide 3/4 by 3/4. 3/4 divided by 3/4. Well, are we allowed to divide fractions? No, we're not allowed to divide fractions. What's the rule? You flip the second guy and multiply. And that's its multiplicative inverse, or the reciprocal, and a number times its multiplicative inverse is 1. See why we were doing those properties last unit? So we'll just take the shortcut and say, well, we're going to multiply by 4/3. And whatever we do to one side, we do to the other. Now this 9, we need to make it 9/1. Over here I have 4/3 times 3/4. That's 1. We just proved it here. So I have 1 times a minus 5, or just a minus 5. And on this side, if I multiply across, I get 36/3 or 12. 36/3 or 12. I could also do a shortcut here. I could say any numerator can cancel with the denominator if they have a common factor. And 3 and 9 have a common factor of 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. And then it's 3 times 4 is 12 on top. 1 on the bottom, I still get 12. And then my last step is I add 5 to both sides. So A is 17, and that will check correctly. Okay, so I want you to do this one right here. You're going to pause the video, and then you're also going to show your check. So go ahead and do that right now. Okay, so this one ended up being 4. I multiplied by 1/2 reciprocal, which is 2. So I'm really just multiplying both sides by 2. I get my two-step equation, x is 4, and then remember I said to show your check. It works out perfectly, 7 equals 7. Okay, so let's look at our last problem on here. We need to make sure we remember what perimeter is. So if I say find the perimeter of the triangle, what does the perimeter mean? Perimeter means that you add up all the sides. It's the distance around. Like if I had a yard, my yard at my house was a triangle and I wanted to put a fence around the yard, that would be the perimeter. Area is the shaded area. So perimeter of a triangle is just side plus side plus side, especially of a triangle where the sides are not equal, and clearly these are different lengths. So I would add up all the sides. So I'd have 3x plus x plus x plus 2. So there's my one side, my second side, my third side. Can I simplify it all? I sure can. What's in front of these x's? 1s. So the perimeter is 5x plus 2. And that's all I could do in this problem, unless somebody came along and said, hey, by the way, x is 7 or 25 or 34 or whatever. Okay, so let's look at the back of your paper. The back is 3, 4, and we're going to be solving when there are variables on both sides of the equation. The vocab here is you're going to identify an equation that is true for all values of x. So maybe 1, maybe more than 1, maybe none. So when you end up with the same expression on each side of the equal sign, that's kind of what we're looking for when it would be like a perfect match, and we're going to see that right now. So for example, 2x plus 4 equals 2x plus 2 times, the quantity x plus 2. So we're going to distribute, and we get 2x plus 4 equals 2x plus 4. That matches perfectly, doesn't it? What that means is it doesn't matter what number I plug in for x, it's going to work. Every x is going to work. It's perfect. It's the same thing. So what I can say is that this would be infinitely many solutions, or the solutions would be all real numbers. Now, I'm not going to write it on here because it's going to smush into this problem here, but you're going to remember that for later. That was just a little sneak peek. All right, well, let's look at this guy now. We have variables on both sides of the problem here. What I basically have is I have 4 a's or 4 x's on one side and 9 on the other. I can't combine them and make 13. I have to get rid of one of them. I personally always get rid of the smaller one because then I can avoid dealing with negatives as much as possible. Not every time, but most of the time. So if I subtract 4a to both sides, I only line it up under the a's where the like terms are. I'm now left with 15 equals 5a minus 5. And what do I have? A normal old two-step equation. So 5a is 20, divide by 5, a equals 4. And I usually write it so that the variable is first. If we check it, I'm going to see if I can squeeze my check. Actually, I'm going to turn my paper to fit my check in here. 15 plus 4 times 4 should equal to 9 times 4 minus 5. So on this side, it's 15 plus 16. On this side, it's 36 minus 5, and they actually both equal 31, so I know I did the problem correctly. So this is a problem that has only one solution. The only number that will work is x equals 4. Okay, now you're going to do this problem on your own. Pause the video and see how you do. Okay, this problem had one solution as well. It's t equals negative 15. Remember to distribute. Did you get the 18 over here? And then I subtracted 4t to both sides. You could have subtracted 6t and ended up with a negative 2t on this side, and it still would have been the correct answer. So that is that problem. Okay, so now we're going to move down to this one. Identify the solution of the following equation. So what I'm going to do here is I'm going to distribute. First of all, you probably noticed that's my first step. So it's 4x plus 5 equals 4x plus 20. It looked like it was going to be plus 5 like we had up there where it matched, but it didn't match. They're slightly different. So what I need to do here is I need to solve. I'm going to get rid of the variables like we've been doing, and when I subtract 4x to both sides, what happens? They cancel, and I'm left with the statement 5 equals 20. Does 5 equal 20? Absolutely not. Well, think about it. What number could I plug in, multiply by 4, add 5, have it equal, multiply that number by 4, add 20? It's never going to work. So guess what? There are no solutions. No solutions to this problem. And that is very possible. So when your variables cancel and you're left with two different constants, there are no solutions to the problem. Okay, the last one we're going to take a look at, we're going to distribute again, just like we just started that one. 6x minus 3 equals 6x minus 3. At this point, you should recognize that it's exactly the same. And what that means is, just like this one, any number can go in there and it's going to work. Any number. However, if you didn't notice that right away, if you start to solve the problem and you subtract 6x to both sides, you're going to get negative 3 equals negative 3. That's true all the time. So at any point in time here, when you recognize this, you're going to say all real numbers are solutions. All real numbers are solutions. Another way we could say that is infinitely many solutions. Okay? And then there's a homework hint here. It says both 49 and 52 in the homework, you need to write an expression for both members and non-members. So you want to know when members is going to equal the non-members cost. When are the costs for members going to be the same as the cost for non-members? So that's a little hint there to help you with your equation work. All right, if you have any questions about the notes, you should see Mrs. Wyman. Otherwise, if you don't have any questions, you are good to go on to the assignments for each section. Good job, guys.